Um, Hello, everybody. My name's Jakob. I'm here with Sukaina and Natasha, and today we are going to be giving you a brief overview of the Python module Matplotlib. If we can take a quick look at the agenda of what we're going to be presenting today. So first, we're going to start off with a little overview of what the point of the package actually is. Then we're going to look a bit at the history and development, and we're going to be looking at how to cite it, looking at some documentation, how it's used, and then of course looking at an example and giving a quick tutorial of the module being used in practice. Can we go to the next slide? So Matplotlib is a library for creating static, animated, and interactive visualizations. Probably for all of us that did stats too, the most similar thing would be in ggplot as something we've all worked with. The point is to develop publication quality plots in a simple way. They're customizable, so you can change the colors and the fonts. Of course, label the axes, everything will be showing you later. And there's packages built on top of it, which will also go into a bit more detail. Can we go to the history and development? So the Matplotlib package was developed in 2002, 2003 by a man called John D. Hunter. He was a researcher on epilepsy data, and he and his research team moved from MATLAB for their data analysis, but they wanted something a bit more flexible and less expensive, so they went about building their own Python package, which could do all the things that that MATLAB, the program, could do. Matplotlib is the oldest and most popular Python package for graphing and for creating data visualizations. And John D. Hunter and his team were greatly facilitated in the development of the package by the fact that it was picked up by the Space and Telescope and Science Institute, which is the science program behind the Hubble telescope. And the Institute supported the development financially and also giving resources to the team to keep developing it. It's open source, so once it gained its foothold and has got a certain degree of momentum, the wider Python community has also been continually updating it and building on the package. As a last point, it has received a bit of criticism in recent years, particularly when being compared to newer tools like ggplot and ggvis in R. However, this is being combated by the Python community, who are continually updating the program and the package, and also building new packages on top of the foundation that Matplotlib gave them, such as Seaborn, which is actually the module we will be using today in the demonstration. And exactly, so this gives it a bit more room for customization and makes it just by default look a little nicer, but we'll see that later in the examples. Yeah, looking at the documentation, so for installing Matplotlib, it would be with this command on your Google Colab. It's already pre-installed, and you just need to import the package that you will use from it. So this command would only be for your Spider if you're using Python on Spider. The most important API is the matplotlib.pyplot, and this is basically what you will interact with and the packages you'll use, the commands you'll use, and these are the functions that make Matplotlib act like MATLAB in Python. So each function in the package will allow you to make specific changes to specific aspects of the figures. Of course, Matplot is often used in conjunction with other packages, especially something like pandas, because for visualizing data, of course, first you need to load it and order it and clean it to present it in a organized fashion. And of course, you use the stats module, SciPy, and because here you can run analyses like OLS regressions and correlations to then plot them and visualize them using Matplot. Next slide. And exactly, this is what we talked about, as that there's some more modern libraries. The base version of Matplot has been criticized as being a bit clunky and not so intuitive to use, and takes more commands to make it look a certain way. So this is why people have gone about developing for something like Seaborn, which is the one we'll be using today. As I mentioned, the base version of the graphs look a little better. And we also have some other examples here of modules that have been built on the Matplot foundation. However, we'll only be focusing on Seaborn today. Next slide. And yeah, just as an important thing to mention, so if you are using Matplotlib in a paper you're writing, for example, you are expected to cite it, and this is how you would cite it.
Thank you for that intro, the history of Matplot. And now we're going to just talk about how we import it and use it. So we imported using the Matplotlib pyplot as PLT, and we also import numpy as PN. So every polyplot function within Matplotlib, it actually allows us to create figures, create plotting area within that figure, make lines, and then also decorate that with labels. Next slide, please. So coming back to the basics of what we have learned so far in terms of data structures, which is variables, values, and assigning them. So it's quite easy to do this in Matplotlib. And as you can see, you can assign variables and values to them. You can code them, and the result is the graph that is coming up on the next slide. So with the code that we had put in, we were able to get 3 graphs, bar graph, line plot, as well as scatter plot. So this is how we can do categorical plotting using the functions within Matplotlib. Can we go to the next slide, please? This is another further example. The previous example had been using variables like apple, oranges. So now you can see how we can easily use the same means to group, to make categorical variables in data terms that may be relevant to our field of research. So we can group things as group A, group B, group C, and then plot them out. Next slide, please. We can also do this with lists. So we can define what the x-axis is and the y-axis is in terms of lists as well, and then we can use this. This is an example using line plotting. So over here, what we have done is we've plotted them using the plot function, named the axes using the x label and the y label functions, put a title, and also then printed it using the show. Could we go to the next slide? Lastly, I wasn't able to find a direct example for an argument, a what-if argument, but what we could do using Matplotlib is to kind of filter the data to see if it needs to reflect a graph or a plot that showcases data that meets a certain condition. So for example, if we have a question which is how to only plot data in the XY data if the X entry meets a certain condition in Python. So this is just an argument for us to try and filter the data. So as you can see over here, we've created a new variable of which is an X filtered list in which all data points within X which exceed or are more than 10 are included. If we can go to the next slide. This is how you can utilize Matplotlib in order to showcase data while including or excluding certain data points that meet preset conditions within your research.
So let's get started. So we'll get started first with importing the package and the dependencies. And here we'll see we're going to use the Matplotlib inline so that the images show up actually in line with the code. And we'll import Matplotlib pyplot as PLT, which is just standard shorthand. And then we'll import numpy as NP. And numpy will give us the arrays that we need to create some data for our plotting. So there's a number of different sections in this notebook, but we're really only going to focus on getting started with Matplotlib and then doing some sample data visualization. So let's start with plotting just some basic curves. We'll be looking at y as cos x, so simple statistical curves, and we'll use the numpy arrange function here, which we can use, so we'll include a start, a stop, and then a step here so that we can plot an X and a Y. And we'll use the plt.figure command and set the figure size, and then plot. We can plot the X and the Y using the dot plot command. And so we can also set, you'll see here, X and Y labels, and the label text also accepts common LaTeX syntax, but you can also just, if you're not familiar with LaTeX, you can just remove these commonly used $signs for math mode, and it'll still give you the same thing. So we can also set the legends and line colors and styles and markers. And so here we create some more data, and we basically focus here on specifying the color, line style, and marker using keyword arguments. So we can set the label, we can set the color using color, and then line style. And here for line style, you'll notice the two dashes will create this dashed line, and a single dash will create a solid line. And then we have a marker which is just S and O, and so here that shows up in the legend. You can also set the legend using LOC, best here using the .legend command. Then we have the X labels and the Y labels, and again, if you run this, it'll just give us what we've already got here. So we can also draw this using positional commands, but unless you're really sure about what that is and how to use it, I wouldn't suggest that you start exploring with positional commands. But we are particularly interested, of course, in making our data and our plots look very nice and appealing, and also providing a great number of information within the plot. So we can set the font sizes, the axis, like the font size for the axis, the text, the type of text, the font size of the text, and whether the legend has got a specific font size. You can also set like different types of fonts. And these all use the .rc command here, which if I hover over this, you'll be able to see what that is. So the RC here is just a command that tells Matplotlib what kind, or pyplot here, what kind of settings we're using for this specific plot. So in this particular operation, but of course you can change this for each plot. And so every time Matplotlib loads, it will define this runtime configuration, which is what the RC stands for. And so you can create default styles for each type of plot element, and those basically stay, they're just retained by the package while you're working with it. So here we add a grid. So that's a new thing we're doing here. We just add a grid, and that you can see shows up in the background. And so sometimes, and particularly in the plot that we saw earlier, we might be interested in comparing multiple plots side by side. So for example, for the categorical plotting that we did. And so in order to do that, you can use this subplot function. And subplot is really interesting here because it allows you to plot any number of plots kind of stacked on top of each other or left like side by side. And so here we specify that we want 2 plots and we want them side by side, and that's what the 2 ones are. So 1 column, and so 2 is just the number of plots, and then we have 1 for each of the plots. And then you can also specify the different labels here. You can set the legend, and we're just plotting the normal sine curves here. And if you hover over them, again, it gives you a lot of information about the kind of parameters you can also set. And so here, if we press, if we run plt show, it'll just show you the command. So how in R you would use the plot command, or you can use print with the name of the object that is a plot, and it'll just show you, it'll just display the plot. You can do the same thing with Matplotlib. And so we can also set common, another like cool thing about this is that if you've got multiple plots that are on the same scale, you can set a common scale. So you see here, this is very different because these are the same scale, and we don't want to retain, just in terms of aesthetics, we want to retain a common scale here. You can set that, and you can do that using index, this particular index, which specifies, which gives a number to each of the plots, and then you can just stack them on top of each other. So what about bar plots? Again, very easy. The syntax for this is plt.bar with the X and Y and the labels. And then you can tack on as many commands for legends and for colors and for lines as you want after that. So what about multiple axes? Again, possible. And you can do that using the, so here we just made up some data, but you can use the plt subplots function again, specify what kind of plots, like the number, the type of plots you want stacked on top of each other. And so here we're actually combining 2 plots, right? So we've got a bar plot in the background. We've got this line plot on top. And so you can define that using the AX axes with the number of the plot, so 1. So the first plot, and the first plot here is, you can see the bar plot in the background, and the second plot here is just the line plot on top. And this dot twin X just means they're on the same, they're plotted on the same X, or you have like multiple, you can also have multiple Y labels here, Y axes here. Same thing with a scatter plot. This is particularly useful, of course, for your linear regression, so like visualizing a linear regression and like some superimposing a line of best fit on actual observations. You can also use like masked scatter plots, which is like a more advanced kind of scatter plot where you're basically kind of masking some of the data, which is perhaps missing data, and you're creating a kind of visual, I guess you could say, a line between the data that you're that you're focusing on, the data that is not particularly relevant. You can do more advanced plotting. You can do contour plots. This is a contour plot. It's kind of 3D plot. You can do a quiver plot. Again, this is a kind of 3D plot that uses vectors, and then you can combine them. You can do 3D faces, which is those like quintessential like MATLAB kind of graphics. And so you can really see here, there's not a lot of room for like cool aesthetics with Matplotlib because it's still very, it still looks like the kind of thing you'd see in an old physics textbook, right? So what about using Matplotlib with some of the newer packages or the newer kind of supplementary modules? So we're going to use this Seaborn API. And I'm just going to mount my Google Drive because it's got some data from the California housing prices. It's already mounted, so I'm going to pretty much just ignore this. And so we import here a number of different packages. We import pandas, we import NumPy, we import Matplotlib, and we import Seaborn. And I'm just going to stop that. Does not matter. And so let's create some box plots. So we've read in the data using the usual syntax that we've just learned last week about reading in data. We drop the NAs. Obviously, for box plots, you can't have NAs. And we draw the box plots. We set the size of the figure, and then we use this syntax here, SNS, which stands for Seaborn, and the box plot function from Seaborn. We read in the data that we're interested in, the X, set the Y, and then the palette. And you'll notice, actually, it's really interesting because the palette and the kind of syntax here is very reminiscent of the way that you use ggplot in R, or you plot like different types of box plots in R. So it's very intuitive for people that have particular R inclination. And so this gives you a much nicer plot, right? And so you can also do the same thing for a number of different kinds of graphs. You can do it for a correlation matrix. Again, it pretty much stays the same. You just have a heat map. You set whether you want it annotated, what you want the data to look like, what the color variation is, and then you kind of take it from there. And it's pretty simple. You can also combine it, of course, with the usual plt.title or the different like X or Y titles and stuff. So you can obviously combine it with the existing capabilities of the pyplot package. And so that brings us to the categorical variable. Again, we've already looked at this, and we can also do really complicated, really pretty graphs. There are, just as a final point, there are some really cool widgets available for Matplotlib. So you can control variables interactively. Now switch over back to some other examples. And so here we've got some examples of multicolored lines that you can do in Matplotlib. You can use the v-lines and h-lines function to create lines that are horizontal or vertical. You can also create really complicated and interesting plots. So here we've got a contour plot, we've got a stream plot, we've got time series histogram. Whether you end up using the vast capabilities of Matplotlib or not, it's nice to see that there's something for everyone, right? And so you can even use it, and this is really, I was really surprised to find that you could use it for creating timelines for different things. Again, they're not really interactive, but if you really want a timeline that looks polished, you could probably use it for that. You can find more examples by clicking on the More Examples thing, which will take you to the gallery at the official site for where all the documentation is for Matplotlib. And you can basically go through this in your own time. And there's so much stuff here. You can spend hours doing this. So I think that brings us right to the end. We will make the code and the notebook and the slides available on the student forum. But thanks a lot for listening, everyone. And if you have any questions or comments or suggestions, let us know. Right. Bye.